There's many ththings that can go wrong. And I think Jacques already touched on one of them, is that with ML systems, they tend to fail silently. You could have a perfectly well-functioning model and you just start feeding it in, like the input data starts becoming garbage in production, like a bunch of inputs turn into nans or like they have outliers in them. And the model could still output a reasonable prediction, right? Because at the end of the day, it's like a bunch of numbers going in and like maybe a single number coming out. So you may never catch what might be happening with the model until someone who owns the business function realizes predictions are wrong, or you get pinged at live AM saying the model is sending shipments to Australia when it's supposed to go to somewhere else. So these are like big failures, but I guess like the core idea is like ML models can fail silently. And they can fail for like multiple reasons. This could be that your input data starts to drift. So this is when, let's say, you've trained for a particular distribution of events or features, and then in the real world, this distribution isn't really met. And so because of that, your model, like the expected predictions don't really match what you had in your training set. The other thing that could happen is your target could drift. So let's say like you trained your model on data that came from like pre-COVID times, right? So like sales for a particular product, let's say toilet paper, had an expected volume. And then you're predicting post-COVID time, where COVID happened, people start stocking up on toilet paper and you cannot like keep up with the supply because there's this huge spike in your target volume. So that's how a target can shift. And I think there's another case, Jacques, correct me, I'm having trouble recalling it, like both things can shift, like your input, like your whole input domain and your target can shift. But I forget what the formal term for that.
I think it might be the covariate shift, but I'm not entirely sure either. But it's when the relationship between your input and your output changes. Yeah. So while the overall distribution of both might be similar, they actually end up being related in a different way.
Yeah.
I think bouncing on what Dhruv mentioned in terms of a lot of the failure modes, I think there's a lot of discussions about data drift and concept drift in general. And those are a lot of the examples that Dhruv have mentioned. But when you think about how those happen, they tend to be long-term failure modes. It's over a period. And of course, you have events that are going to create shifts in the distribution very quick, but often there are things that are going to happen over days, weeks, or months. And there are things that you can also estimate on your training data. You can do out-of-time validation, where you train your data on data from 2 years ago and then evaluate it on data from a year ago. And then you can see, okay, how quickly over time does my model performance start to drop? And so that is out-of-time validation, which is different from the cross-validation, where you're going to be randomly sampling events. But so you can do that validation and it can give you an indication of how quickly data drift has happened historically. Still important to track it in production, but so those are what I tend to call the kind of long-term data issue, like performance issues that you're going to see. But very often the reason why you're going to be woken up at 3 a.m. or that you're going to have to quickly shift from one project to another is for more kind of abrupt changes in model performance. And those actually end up being often tied to the system itself. So one of the examples that I've seen in the past is for your machine learning model, you ingest a lot of data. And one of the tables that we were ingesting were foreign exchange rates. So how much is a pound versus a dollar? So we could do some currency conversion. And that table stopped being updated. The database and the other team that was responsible for that table decided that it was no longer required. And therefore, they stopped updating it. The model still works. We can still do all of the currency conversion, but the data starts being out of whack. And so that will result in very quick, abrupt changes in data. And you'll also have databases that are dropped by mistake, or kind of upstream data collection processes that stop working. And then you're going to have system failures. So you might actually have environments that no longer work, Python dependencies that result in breaking changes when you do an upgrade. And so I think it's really important when you're thinking about your monitoring system to think about the long term. Okay, how am I going to track the degradation in performance over a month, like a week, a month, a year? But then also, how quickly do I need to know when something goes catastrophically wrong? And those are really the two things that you'll end up having to balance.